you can't forget the classics like the Raven or the Telltale Heart. Like those are the classics, and those are technically poems, so that's whatever. Or, I mean, well, the Raven is technically a poem.
Raven is, I don't know.
I do really like that one though.
Raven is good. Is Telltale Heart poetry?
No, that one's more of a. That one's one of their. That's one of his tales. Yeah.
Correct.
Yeah. Yeah.
That would be Poe's prose.
I was waiting for it. I was waiting until you were gonna make some like poetry joke, and then I'll get to go. Boo! Get off the stage. You're not funny.
Ah, but I went for the prose instead.
So I'm not gonna boo you quite as hard.
Oh no. I would whine about, oh my gosh, people that love Poe, but I also really like Lovecraft, so like, like it's gonna be kind of hard to, you know.
No, I'm glad you're self-aware.
I do think Poe is great, and I do think you genuinely like Poe, and who knows whether he will as he gets into it. He may or may not. We shall find out. But plenty of people, they're like, oh my gosh, I love Poe for my dick. So like, shut up, kid. Yeah. Go read your poetry at home. You'll be fine.
That was my mom.
What is this? Bruh, why is this? Where's the test? Do you have the test? Why is this? Why did you do it on paper and then copy it? Like, I don't understand.
Because I had lost the original paper, so.
I see.
It's like a sad little photo.
That doesn't make any sense. You lost the original paper. Why did you photocopy it in the first place? Did you have a premonition that you were going to lose it? Is that what happened?
I thought, okay, I should probably take a photo. I should probably use the scanner and scan this.
Why?
Remind me. I have a question for you, because this is flashing back to a particular moment in my days at college. Do you have siblings?
Too many.
Do you?
3.
Okay.
Because I wanted to use my scanner as giving only child vibes.
Correct.
Which is not a bad thing. It's just giving those vibes.
I'm last child vibes.
Youngest child.
With lots of siblings. Okay, now we're seeing the dots start to connect.
Yeah.
Okay. Okay. All right, we did 4-3 and 4-4, or 4-4 and 4-5. Where are we at? What are we doing? Okay, I was right to begin with. Look at me. All right, 4-3. What numbers did we do? 2 through 48 evens. Number 2. 8x squared minus 4x plus 3 equals 0. Number 4. 5x times the quantity 7x minus 3. Number 6 is x minus 8 times x minus 4. Number 8 is quantity 2x minus 5 times quantity x plus 6. Number 10 is negative 6 and 6, or plus or minus 6, however you want to write that. 12 is negative 1/3 and 1/2. 14 is negative 4 and 7. 18 is 2x squared plus 9x minus 5 equals 0. 20 is 8a times quantity 5a minus 4. 22 is 8x minus 3a times 4y plus 5b. 24 is 15 times quantity y plus 4 times quantity y minus 4. 26 is quantity x plus 8 times quantity x plus 5. 28 is 3 times quantity x plus 6 times quantity x minus 2. 30 is quantity 4x plus 5 times quantity x plus 6. 32, strange. 32 is somewhere. There it is. 4z squared times quantity 2x minus 3 times quantity x plus 1. 34 is 6y squared times quantity 3x squared minus 4x plus 6. We go through 42? Yeah. Okay. Number 36 is negative 7/4 and 2/3. 38 is 5 and negative 9. 40 is plus or minus 11. 42 is negative 4 and 2/3. What questions do we have?
Can you do 2?
Yep, we can.
I thought we went through 48 for this lesson. I thought 42 was the next lesson.
Oh, yeah, it was 48.
Oh, number 4 is 7 centimeters, 24 centimeters, and 25 centimeters. 46 is x equals 10 and 8 feet by 12 feet. And 48 is x equals 12 and it's 14 feet by 32 feet. Number 2, we're supposed to write a quadratic equation in standard form with the given roots. And the roots are 3/2 and 1/4. So there's kind of a couple different ways to look at it. We'll do it the most straightforward way, where we deal with fractions first and then kill them in a minute. If you want to think about it another way, you can. You can kill the fractions from the beginning, but I'm not going to explain that right now. Okay. So this would be x minus 3/2 times x minus 1/4. Great, grand, glorious. That's an equation. It's a quadratic. It's just not in standard form. So what do we got to do to get it in standard form? I love that idea. Anybody have any others?
Do we follow the steps backwards of normal after?
Well, kind of. Yeah. Yeah, kind of. If you want to describe it that way, yeah. Technically, yes. What does that mean? We just distribute, right? Is that the word? Is that the words we're looking for? Right? We unfactor. We distribute.
I love that idea.
What's x times x?
X squared.
X squared. What's x times negative 1/4?
Negative 1/4 x.
Negative 1/4 x. What's negative 3/2 times x?
Negative 3/2 x.
Negative 6/4 x. I agree.
Yes.
Jameson, you just really got it.
Same thing, okay.
Negative 3/2 times negative 1/4. Positive
7/2. Wait.
3/8. Because math.
Am I failing?
No, you're just kind of falling apart. That's okay.
6/4.
I just turned 3/2 into something with fourths so that I can combine like terms. Because math. Because why calculator when we can brain?
The interaction, like that would slide perfectly into like a Midwest emo song. Am I failing? No. You're just falling apart, but that's okay. Like that's so very
Perfect
Midwest
lyric.
emo.
We just need a melody. Somebody get on that.
Midwest emo does not have melodies. They have basements and iPhone 8 recording devices.
All right, what now?
Combine like units.
Great. Where are they?
6/4, 1/4, or negative.
Yeah. What's negative 1/4 plus negative 6/4?
Negative 7/4.
X.
X, yeah.
Now, in order to be standard form, we can't have no fractions. So, what should we do?
Divide it by
What? Divide it by 4.
I mean, multiply it by 4.
How about 8?
But wouldn't the 4 not get eliminated?
Well, if I multiply it by 4, then this is just going to turn into a 2 in the denominator. And I want all the fractions to go away. I want all of them to piece out, homie. Multiply it all times 8. So 8 times x squared is 8x squared. Wow. Negative 7/4 times 8 is
14.
negative 14. And then 3/8 times 8 is 3. And then there it is. Look, Mom, I did it. What other questions from this lesson did we have? Sure.
I was just about to say, why don't we do 20?
I see.
What page are we on? I forgot the paper that I have to do.
Oh, no.
244.
244.
I also totally forgot to like turn it in, so I could totally.
Oh,
I could be
no.
lying. Maybe I just didn't do my homework at all. You never know.
That's true. I would also never care. It's not my problem.
Technically, you'd know once you got my quizzes and tests and things. But
Well, yeah, I would have some suspicions if your grades were markedly different from normal. I would have some thoughts. Number 20. Oh, yeah, y'all want to do the easy one. All right, why not?
riddle.
What should I do?
Pull out 8A.
Sounds great. Let's pull out an 8A. Oops. When I pull an 8A out of the first one, what's left?
5A squared, or just 5A.
5A. When I pull an 8A out of the second one, what's left?
Negative 4.
Negative 4. Bless you. What else should we look at?
Can we do 22?
22. Sure. Don't forget this method that we're about to do. Because if you remember it next year in pre-cal, you may get to the test that they took the other day and be like, oh, there's an easier way to do this. I don't have to go to all this trouble. You might forget, but.
I actually liked this lesson.
Well, good. That really wasn't really the point of what I was saying. But I'm glad you liked it. You said that about several lessons here recently. Hopefully your like translates into understanding and, hard work.
And dedication.
You don't have to dedicate anything. That's overdoing it.
Dedicate my life to become a mathematician.
You could, although I don't know if that means what you think it means. Being a mathematician is a lot different than what people think it is. And it doesn't look anything like this. Anything like this, like literally at all. Zero like this. Even being a physicist doesn't look like this. You want to know what the only job on the planet that looks like this?
Teaching math.
Math teacher in high school. And maybe a little in college. That's it. That's the only job that looks like this. That's the only one. You will never do this in a real job except teaching. Facts. Anyway.
If I were a lesser student, then I would ask why we're doing it at all.
Yeah, but you've heard me explain that many times, so you probably remember. You might ask it anyway just to be obnoxious. I mean, that could happen.
Definitely the plan. I do a lot of things.
What should we do on this problem?
Maybe take out all the variables.
Well, kinda.
Would you find that they come after?
Kinda. No, I'm just kidding. What?
We have to split the equation into 2 halves.
We should split it into 2 because we can factor this by grouping. All right, that was actually right. That was a premature no. So
I'm not
sad.
failing yet.
Nobody said you were failing. Nobody said anything about failing except you and maybe your mom, I guess. I don't know.
Yeah, that happens.
Savage. Okay, now what?
We factor out the first equation, AS.
Sounds great. Let's do it. We factor an 8x out of the first term. What's left? 4y. When we factor an 8x out of the next one, what's left?
5B.
5b. Now what? Negative is correct because we want the signs to match. Negative 3a, right? Factor negative 3a out of the first one, and what's left? No. Yes, 4y plus 5b. Imagine that, they match. Pull out a 4y plus 5b, and we're left with 8x minus 3a.
I like how everything just works.
So cool. Wait till we get to rational equations, we start just like disappearing stuff. Like an assassin.
So stuff just disappears?
No, you disappear it. You cause the destruction. It's so much fun.
Oh my gosh, math teacher teaches students how to be hitmen.
Yes. Math teachers teaches students how to hit on their exes. That was good. That entered my brain, and that worked really well. That one is shirt worthy. I think that's one of the funniest, actual funny. You know, I say all kinds of stuff that students laugh at that is not funny, but that one was funny. That one was good.
I have in the margins of my notes, I will sometimes just write kind of dumb things that you say. It will be like Sean Fulkerson, eccentric math teacher.
There you go.
I'll just write quotes, and so you get another quote added.
All
to the
right.
margins of
Well,
my
there you
notes
go.
today.
There you go.
That was great.
All right. Any other questions from that lesson?
Whenever you're like, all the ones that don't equal 0, do you just put them equal to 0?
What?
Does it matter? Because it says factors polynomial, but none of them are equal to 0.
So so you just factor it. You don't like find the roots. Like you don't set each factor equal to 0 at that point. Like the answer to 32 is like all that stuff. 4z squared times 2x minus 3 times x plus 1. Not negative 1, positive 3 halves, and 0.
Can you do 48?
Yeah, we can do 48. Find the x dimension of each rectangle. X and the dimensions. We got a rectangle. His area is 448 feet squared. And this dude is x plus 2 feet. And this one is 3x minus 4 feet. How do you find the area of a rectangle?
You multiply the base and the height.
Yeah, base and height, length times width. Great. So this times this equals that one, right? X plus 2 times 3x minus 4 equals 448. I don't know if y'all knew this or not, but 448 is not 0. I know, shocking. So we can't, even though it's factored, just like set it equal to 0 because 448 isn't 0. So we got to undo it and then redo it and then do it again, right? So what do we got to do? Distribute. What's x times 3x? 3x squared. True enough. X times negative 4 is what?
Negative 4x.
Negative 4x. 2 times 3x is what? 6x. 2 times negative 4 is what?
Negative 8.
Negative 8. There we go. What should we do next? Combine like terms and go ahead and subtract that 448 so it's over here with his friends. So we end up with, of course that has to be a 3, stupid odd number. 456, right?
It's a year.
It's a year. I don't think so, bro. A year is not negative or 456. But I can see where your mind went. I can see the tangle that happened. I get it.
My brain is.
It's totally something that I would do.
My brain is.
I am old enough now that I might, I stress the might, have not said it out loud at this point. But it's definitely something my brain would have done. Anyway, what now? We got a factor.
I see a 5 and a 6, and I'm like, yes, year.
Yeah, we understood.
Yeah, brain does that.
We got the joke. It's okay.
Now what?
We gotta find the factors of what goes into 456.
Yeah, pick one and go.
Yeah.
You should probably be like smashing buttons at this point, unless you're like really good at doing 2-digit at multiplication in your brain. And then if that is something you are good at, I should tell you that you can make a homeschool team and compete in UIL now. You can go do number sense. It's a thing that could happen.
See, I did UIL as a public schooler, and I would prefer not to do that.
ULL is all right. The only math competition, in my humble opinion, that is any fun is, in fact, number sense. Calculator's boring, and mathematics is just hard. Number sense is fun. You learn tricks and do stuff and whatever else. And it's short. It's like 10 questions, so, it's great.
I guess I just only did the boring ones.
The worst, having been a public schooler and graded lots and lots of UIL, the two worst to grade are spelling and this is kind of a twofer, but the recognizing art and recognizing music, because middle schoolers spelling and handwriting is fun.
Yeah.
And those are pretty brutal, because if you miss one letter on this composer's name or whatever, you just screwed it up. Anybody have any factors of 456 yet? You should be doing 456 divided by enter.
Sorry, I forgot my calculator now, but it was gonna be
9 plus 6 is 15.
4 and 114.
4 and 114. 4 times 3 is 12 and 104. Yeah, it's not going to be that one, but thanks for finding one. Let's find ones that are a little smaller. Good job. Way to play along. 12 and 36. And he sounds like it's confident. Let's see.
There's also 3.
12 out here and 36.
And 38.
38 makes sense. I was like, that's not going to work if it's 12 and 36. Okay, we put the 12 out here, and then we got 3 times 12 is 36. 38 times 1 is 38. Can we add or subtract them to get 2? Yes, we can. Minus, plus, follow our nose and follow our mouth. He's working. The sign works at the end because a positive times a negative is a negative. Great. So x equals negative 38 thirds and 12. I suspect one of those we're going to throw in the garbage. What do y'all want to bet in this problem?
The 38 thirds.
Probably. Not because it's 38 thirds, because it's negative, but if we plug in negative 38 thirds, which would be what? 36, 30, that'd be 12. 12 and 2 thirds or a third or whatever, I don't care. Just the fact that it's negative and it's bigger than 2, right? Which is going to make this dimension negative. Can't have no negative distance. So that one's going to toss in the garbage. So 12 is x. And we shove the 12 in there, and Bob's your uncle and done. Every time I say that in Algebra 1, I can't remember who it is. I think it's Charlotte, but it could be somebody else. I don't really remember. Somebody's always like, my uncle is Bob. Okay, great. Any other questions from this one lesson? All right. Let's go.
This one's fun. I like this one a lot.
Let's get some eyes in the mix. Where did we go on this problem? How many did we do?
2 through 40.
2 through 4. There's no way we did 2 through 42. 2 through 40 makes sense.
Yeah, we did 2 through 40.
Was it 40?
There's no way I just assigned 1 from that section.
Yeah, we did 2 through 40.
Did you suffer through 42? You're like, well, that was one I was going to ask about, but never mind.
That one does look
Number 2.
decently painted.
4i times the square root of 2. By the way, numbers, now this is, many of you will have to dig through your menus to be able to figure out if you can even put these in the calculator. And plenty of them will just give you an error. But if your calculator happens to be able to spit out an answer to this, number like 2 through 6 are problems that if you just wrote the answer, it would be wrong, because I needed to see that you know how to do it, not that that your calculator can spit out an answer. Does this make sense? Yes. Okay, good. Number 2 is 4i times the square root of 2. Number 4 is negative 72 times the square root of 3. 6 is negative I. 8 is plus or minus I. 10 is 5 and 3. 12. Did I omit 10? No. Okay, well, we probably could have. But if somebody wants to do it, it's not hard, actually. Anyway, moving on. 12 is 6 plus 2i. 14 is negative 14 plus 8i. 16 is 16 61ths minus 7 61ths I. 18 is 11i. 20 is 10i. Negative, excuse me. 22 is negative 42i. 24 is negative I. 26 is 16 plus 2i. 28 is 3 plus 7i. 30 is 5. 32 is 18 minus 30i. 34 is 1/2 minus I. 36 is plus or minus I. 38 is plus or minus 5i. And 40 is plus or minus 3i times the square root of 2. What questions do we have on those? Number 2, sure. The instructions say simplify. What should I do?
I'll pull out an I to make 32 positive.
Great. Pull out an I, which kills that little negative in the square root. Square root of 16 times the square root of 2 is true enough. What's the square root of 16? 4. What other questions do we have? 10? Yeah, sure.
Would it have to be plus or minus 2?
No, because we didn't solve equals. Like if there was a, like the square root of positive 16 is 4. Square root of negative 16 is 4i. We get that when we take the square root of both sides, like on an equation. Mm-hmm. Number 10, the big fat hen. Great. You were like, he said it was easy, but I didn't know how to do it. Ah. We're supposed to find A and B that make this true. 4b minus 5 plus negative A minus 3i equals 7 minus 8i. So, what should we do? Yeah, kind of. What do you mean?
Like you do 4b minus 5 equals 7.
Mm-hmm.
Where does
Nowhere. So, okay, so the reason why you can do this is because this is like in complex form and this is like in complex form. So this is the real part and it equals this real part. And this imaginary part equals this imaginary part. And so you're just kind of setting the coefficients equal to each other is what you're really doing. Yeah. And then you keep on solving those little baby things.
Oh, I liked this one. This one was fun.
I just did because you can divide off the eyes.
But then you would have eyes underneath this and this and.
But when I explain equations.
Oh yeah. So if you had an eye here and then yes.
I just screwed you with that eye. I got a lot of eyes.
Yeah, and then it just like fell apart from there.
Well, no, that's
Oh.
11.
You got 11. Well, you probably made an arithmetic mistake. Honestly, probably. Okay. What other questions from this lesson do we have? Sure. I over 5 plus 6i. Okay. Now what?
You multiply by 5 minus 6i.
True enough. Because we don't like square roots in the denominator. So we multiply by the conjugate. In the numerator, we got to do everything, right? First, outside, inside, last, all the things. What about the denominator?
Have to do the same thing because
Nah, bro, because the outside, the inside are always going to cancel. Always in the denominator. That's like the whole magic of multiplying by the conjugate is that outside, because then we don't got no more eyes. So all we have to do is full, not FOIL, right? On the denominator. Numerator got to do everything. So 2 times 5 is 10. And then 2 times negative 6i is negative 12i. I times 5 is 5i. I times negative 6 is negative 6i squared. Which if this was pre-cal, I might have skipped and been like just positive 6. But we don't do that right now. In the denominator, just the first and the last. So 5 times 5 is 25. And then 6i times negative 6i is negative 36i squared. Now what?
combine my terms on the top.
Good. Where are they?
12 and negative 2 and 5.
12i and 5i. Sure. What happens to that I squared?
It changes the 6 to a positive.
Yeah, it's negative 1. So negative 6 times negative 1 is plus 6. And then negative 12i plus 5i is what? And in the denominator, we have the same thing. This is going to turn this into positive 36. So we've got 25 plus 36. Now what? So we have 16, minus 7i over 61. Now, the problem with this is it's not in complex form. We need the real part and the imaginary part to be split up, right? So all we got to do that is just go 16 over 61 minus 7 over 61i. And now it's beautiful. What other questions from this lesson do we have? Sure. All right, now what?
Multiply 3 times 2 and 24 is 18.
Yeah, or we could start like reducing now.
So be 2 and 9 for 18.
Mm-hmm.
And
3 and 8.
4 and 6.
Oh, there should be i's here, right? I there, and there should be an I right here. And the square root of, 4 and 6. Square root of 4 times square root of 6. Great. What now?
4. Square root of 4.
Not clear. I don't know what you mean by not clear, Prince Osai. You're going to have to use more words because simply saying not clear is not clear. Okay, what?
The square root of 4 turns into 2. The square root of 9 turns into 3.
True enough. So 3 times 2 times I times the square root of 6 times 2 times 3 times I times the square root of 2. Now what?
Combine like terms.
I mean, it's not really combining like terms, but yeah, I mean, what you mean is, do the multiplication, right? I times I is -1, right?
Yeah.
So we've got negative. And then 3 times 2 times 2 times 3 is what?
72.
I don't think so. 36. It's going to be 72 in a minute. We're not quite there yet. Something else is going to happen. 36 times the square root of 12. Now what?
Break the 12 into 3 and 4.
Break the 12 into 3 and 4. So we've got negative 36 times the square root of 4 times the square root of 3. Square root of 4 is 2. So negative 72 times the square root of 3.
Wouldn't it be positive 36 because there's 2 negative ones?
No, it's not 2 it's I times I. This one times this one is I squared.
Oh.
So there's only, So there's only one negative one. There's 2. Square root's a -1. I kind of skipped a step there. What other questions do we have?
Can we do 22?
Sure. Make sure that the not clear doesn't mean that my like sound is not working or something. Oh, seems like. Is it working? Yes, it is. Okay, so we seem to be good. I don't see anything weird with our display. So we'll assume that technically it is flawless. Which number did you say?
22.
22. Sure. I was looking at 20. I was like, bruh. But then I looked at and then I realized I was looking at the wrong number. 22 is another monster of a problem. They left. They didn't like me questioning their comment. That's fine. Not my problem. Okay. 22. Negative 3i times negative 7i times 2i. Great. Now what?
Multiply everything together.
Great. So negative 3 times negative 7 times 2 is what?
42 will be 2i.
Negative 42.
Positive.
Oh, yeah. That ain't no small.
42 times I cubed. What does I cubed equal?
Negative i.
Negative I. So negative 42i. Wow. What other questions do we have? 36. Sounds good. The easy way or the hard way?
Let's do both.
We could do both. That is a true possibility. 4x squared plus 4 equals 0. You could solve this by factoring. You could factor 4 out and get 4 times x squared plus 1 equals 0. Set each factor equal to 0. 4 equals 0. It does not, in fact, equal 0. That one's going to disappear. So then we've got x squared plus 1 equals 0. And then we got to do basically the same thing we would do if we solved it the other way, right? What do we got to do to get rid of the 1? Subtract 1. X squared equals negative 1. How do we get rid of the square root?
Absolute value? Or, no, that's not.
You meant the right thing, possibly.
That's not the word.
Square root. When we take the square root of both sides, what do we end up with? Plus or minus. What is the square root of negative 1 equal to? I.
I'm just too tired to do anything today.
You could also just subtract 4 from both sides and end up with negative 4 equals 4x squared divided by 4 and end up with x squared equals negative 1, and we're back to up here, right? What other questions do we have? That didn't sound like a question. You know, oh, that actually worked. Maybe they fixed it. That'd be cool. This watch has this pinch gesture where you can like double pinch or whatever, and it works about 1 in 50 times, at least on my wrist. It may be operator error, but you know, whatever. 16, sounds great. We already did 16. Yeah. Silly Billy. What? 24, sure. All right. I to the 11th. Got to do, in order to get like all the points, you got to like do some like middle school math. So, what do we do?
We gotta split the.
Count.
You divide it by 3, and what's the remainder?
Not 3. But yes.
Divide like 11.
4.
Not 4.
4 goes into 11. How many times?
Yeah,
2 times.
Remainder of
8. It's got a remainder of 3. Therefore, what? It is the same as I cubed, which is, yes, negative I. Therefore, it is negative I. Yes. Now, you can't, like, if it's, let's do a stupid one real quick, just for clarity. Like, I to the 3,241. Great. So, we're going to do 4 into all that mess. So, in your calculator, hopefully I didn't accidentally do something that was a multiple of 4. That'd be funny. In your calculator, do 4 into that and tell me what you get.
810.25.
Okay, I don't care about the 0.25, right? So 810, right? Great. So 810 times 4 is how many? $810 times 4, enter. Thank you. 3,240. So it's got a remainder of 1. So you could show that. Like, you don't have to do like the whole, like if it's a stupid big number, you don't have to do the whole long division down to nothing, right? You can just do this to show that you know what's happening, right? This is enough. Does that make sense?
Where
Because the pattern repeats. It's cyclical of 4.
Okay.
There's I to the first, I to the second, I cubed, I to the fourth. It repeats.
I understand.
Yeah, that's why 4. Yeah, so this would equal I to the first, or I, right?
Would it be plus or minus I because it's
No,
square root?
no. There's no equals. I mean, I know I just drew an equals, but we're not taking the square root of both sides.
Oh, because it's not.
It's not an equation. It's just simplify this ugly nonsense.
You can also find the remainder by whenever you do division. It'll be a decimal of 25, 50.
Sure, that's true. Yeah, it'll be 0.25, 0.50, 0.75. Yeah, because we're dividing by 4. Yeah, so if you number sense a little bit harder, then you could probably get there. But if you show, but I want you to show this much, right? So that so we can see. If you want to write 8.25 and then the thing, that's fine. Like if decimals make you warm and fuzzy because you're a weirdo, then sure, that's fine. Like, yes, you're right. Because quarters. Any other questions from this lesson? Sure. Five over 2 plus 4i. We don't like square roots in the denominator. Can't have no i's there.
Multiply by the conjugate.
Multiply by the conjugate. What would the conjugate be? 2 minus 4i. Easy peasy. In the numerator, we just distribute, right? Everything happens. 5 times 2 is 10. 5 times negative 4i is negative 20i. In the denominator, we don't need the outside and the inside. They're going to cancel, right? So just do the full. The first is 2 times 2. That's difficult. And then we've got negative 4 times positive 4 is negative 16 I squared. So we've got 10 minus 20i over 4 plus 16, right? Because I squared is negative 1. And then so we've got 10 minus 20i over 20. What else do we need to do? Split it. It's also going to reduce. What is 10 over 20 reduced to? 1/2. And then 20i over 20 reduces to what? 1. Negative I. Easy squeezy, lemon peasy. Let's take a quiz. Ready, set, go.